Okay, my 2.7 worksheet. We're done with Thomas's. Now we're going to look at more specifically, as you know, the stuff that's on my math lab. There are 12 questions there. They're fairly simple. You'll find the material because we're going over it for the second time and because it's simpler. You'll find it easier than Thomas's stuff, I think. Okay, so number one on my worksheet asks you, are those two functions inverses? They give you f of x equals 5x plus 9 and g of x equals x minus 9 over 5. I'm seeing here it's multiplied by x. Here 5 is divided into x. That's an indication opposite operations. Plus 9, minus 9. So this is a really good clue that these are probably inverses. Let me show you two ways of proving it to yourself. One way that you can do is to do f composed of g of x and see if you get x. Then do the inverse of that, g composed of f of x, and see if you also get x. If you get x for both of them, they are inverses. So let's try that. G composed of x means take this, x minus 9 over 5, and put it in place of the f function. So that creates f times the g piece. 5's cancel out. We have x minus 9 plus 9, and we get an x. So that certainly passed the first part of the are they inverses test. Let's try g composed of f of x. In this one, we grab the f of x, grab 5x plus 9, and insert it into the g equation. So 5x plus 9 minus 9 over 5 plus 9 minus 9 are gone. So we get 5x over 5, cancel out the 5's, and we get x. So yes, those two are inverses of each other. There's another way to check and see if they're inverses of each other. Of course, that has just slipped my mind at this very second. Let me go back and look at Thomas's notes at what we did there. We can certainly graph them, but that wasn't on my mind. I'll think of it and come back to you on that one, and I may end up having to add to this. I can't find a way on YouTube to pause or on my phone to pause, so I'll come back to you on that. But this is certainly a good way, and then I talked to you about multiplied by, the opposite of that is divide by, add 9, subtract 9. That's certainly another way of checking it. So let's move on for now. Number 2. All are one-to-one functions. That means, remember, they pass the vertical line test for functions. They pass the horizontal test to count them as one-to-one functions. So it says, given f to f of x, find the inverse. So number 2, f of x equals 6x plus 4. We're going to find the inverse. That means, and this is just reminding me now, I can go back up to number 1 and show you. Let's do that right now. Let's finish up number 1. I can take this equation and I can find its inverse just like we're going to do on 2, 3, 4, and 5. And then if it matches this one, we know there's inverses. So let's do that 4-step process. F of x equals 5x plus 9. Let's call this y equals 5x plus 9. Let's swap out the x and the y, so x equals 5y plus 9. Now what we're trying to do is get y equals, get y isolated. So we're going to subtract 9. We get x minus 9 equals 5y. Again, trying to isolate y. Let's divide by 5. Let's swap them out. And then let's call it the inverse, x minus 9 over 5. Now, we took this one and inverted it. Did we get this one? We sure did. We've got x minus 9 over 5 is g of x. X minus 9 over 5 gives us the inverse. So when you're asked are the inverses, you can either fog and goff them to see if you get x's for both, or you can take one of them, doesn't matter which one, swap out the x and the y and solve for y and see if they then match. So either way which way you want to do it doesn't matter. Okay, so let's take this process and do this for number 2. Let me move down here. Make sure we're still on there. Nope, not quite. There we go, looking at number 2. So we'll replace f of x with y, swap out the x and the y, and now let's solve for y. Subtract 4. Still solving for y. Divide both sides by 6. We get y equals x minus 4 over 6. Swap these two sides out. And then rename this one the inverse of x. And there you go. Okay, let's do that to these other problems. Let's see, number 3. F of x equals x cubed plus 5. So again, let's rename this with a y. Let's swap out the x and the y. And then remember, your goal is to get y isolated. Move the 5 over. And then if we want to solve for y, this is being cubed, we need to take the cube root. So cube root there. That'll give us y. That's good. That's what we wanted. If we take the cube root of one side, we need to take the cube root of both sides. So we end up with the cube root of x minus 5. Make these guys change places. And then rename this to indicate that is the cube root, put a 3 there, put a 3 there, that is the cube root of x minus 5. So this is the answer. The inverse of x is the cube root of x minus 5. Let's go ahead and tackle number 4. F of x equals x plus 1 to the 3rd power. Okay, again, you're substituting the x for the y. Well, call this y. Now swap them out. We're creating the inverse this way. Remember that your job now is to solve for y. So the first thing we want to do is uncube that. So I'm going to take because this is raising this guy to the 3rd power, I want to take the cube root of both sides. Do it to one side, got to do it to both sides. We end up with y plus 1 on that side. We end up with the cube root of x on the left-hand side. Still solving for y, you want to isolate y. So move that 1 over. And be careful here. This 1 is not underneath the radical. So it's the cube root of x and then minus 1 by itself. Swap them out. And then rename this as the inverse of our original cube root of, cube root of x minus 1. And notice there are inverse things happening here. Here it's adding 1, here we're subtracting 1. Here's the cube root of x, cubing x, this is the cube root of x. It isn't as clean as the others were because there's more going on. I mean, it's not under there. You might think it should be under there because this was in there. Whatever. There are things that happen that you might not fully understand, but if you process it, you will get the right answer. All right, let's look at number 5. F of x equals 9 over x. They've got an extra little deal handed to you here. You have to be sure that x does not equal 0. That's because if we put in a 0 for x, we're going to get a we're going to get an exploding problem. You can't divide by x. That's against the rules. Nowhere else did we have any x's in the denominators or anything like that to have to worry about. This is the only one. They'll give this to you. You won't have to worry about it. You won't have to create it. You won't have to do anything special for it. So really, you don't need to worry about it too much. Okay, let's see what we're going to do here. Let me scoot me down a little bit, give myself the rest of the room that I've got here. Okay, swap them out. Y equals 9 over x. Then we're going to trade them out. Swap out the y for f of x, and then trade the x and the y out. Okay, what we need to do here is we need to figure out some way of getting y by himself. We're isolating y, and we want him by himself. Cross multiplication is probably the easiest way. Multiply, multiply. So we get xy equals 9 times 1, which is just 9. Still trying to get y by itself. So divide by x. And we get y equals 9 over x, which is exactly where we were before, exactly what we were doing before. Y equals 9 over x, and then exchange this for that. So you end up with the exact same thing, which is okay. That's a weird problem. We did it right. We did the steps right. And we are good there. I'm just checking something in my notes before we move on to the next group. Okay, and then you'll notice that in my math lab, they will tell you x cannot be equal to 0. That's okay. Don't worry about that piece. It doesn't matter to you. It just doesn't matter. All right, let's look at 6, 7, and 8, which don't have numbers on them on my worksheet, but they're the 3 graphs across the bottom. So let's look at, does each graph have an inverse, these say? So let me grab my whiteboard. You will notice I managed to clean up my whiteboard. I found on Google that where I had some, you can still see it faintly, but what I did was I put the Expo marker, ran it all over there, and then wiped it off, ran it on top of the bad stuff, on top of the Sharpie, and then wiped it off. And hey, it worked. So I can continue to mess up on that and know how to fix it. Okay, let's remember that, let's see, let me just pop this in there. This graph is something like that. That's what we're looking at. They're asking you, does that have an inverse? We're assuming it's a function. In my math lab, they tell you they are functions. The 3 that they give you for number 6, 7, and 8, they tell you these are functions. So you know they pass the vertical line test. Your job when they're asking you, does it have an inverse? That means, does it pass the 1-to-1 test? That means, does it pass the horizontal line test? And so yes, there is no horizontal line we could put in here that would hit this line, our graph, more than once. So number 6, yes, that is a 1-to-1 function. Does each graph have an inverse? Number 6, yes, it does have an inverse because it is a 1-to-1, because it passes the horizontal line test. Erase this one. I'm going to try a different marker other than red. That doesn't seem to be working great. Let's look at number 7. Let me get it somewhat drawn in here. Doing something, oh, that's way better. Doing something like that. So again, you've been told this is a function, so you know that it passes the vertical line test. You're asked, does it have an inverse? And that means, does it pass the horizontal line test? And this will not pass the horizontal line test. This horizontal line, beep, that's okay, beep, that's not okay, beep again. So this flunks the horizontal line test, so this does not have an inverse. If we had the equation for this graph, we would not be able to create an inverse for it. And then let's look at number 6, 7, 8. Number 8. Something like that. Close enough. In advance, you know it's a function. That means it passes the vertical line test. They're asking you, does it have an inverse, which implies, does it pass the horizontal line test? And yes, this does pass the horizontal line test. Any horizontal line will hit once, but never twice. Once is okay, twice is a killer. So 6, 7, and 8, number 6 is, yes, it has an inverse. 7 did not, and 8 does. So yes, no, yes on those 3, looks like. Okay, the rest of what we're doing here is graphing, I believe. Yeah, a little bit of work on the number 11 and 12, but for the most part, graphing. So let's look at number 9. Number 9 has pointed out to you a -2, 1 point and 0, what is that, 4, 1, 2, 3, 0, 3. Doesn't matter a whole lot. I mean, you know. So let me draw that in. We want to draw the inverse of that. So let's start by, I want to remind you of what this inverse line will be reflective across what line. So the line it's reflective across goes like that through 1, 1, 2, 2, -1, -1, that kind of thing. That's the mirror. The way to handle this, to me, the easiest way by far to handle this is to take these points and look at their inverses. Let me just do this on, I don't have something small enough. So let me scoot this over a bit. Do it up here. So the points that I've got for my original graph, I've got -2, +1. For f of x, I've got -2, +1. Here we go. And this point is 0, 3. In order to create the inverse, I'm just going to swap these two out. So 1, -2, and 3, 0. And I'll plot those points. That will be the inverse. So 1, -2 is that point right there. 3, 0 is that point right there. And I'll just connect the dots to create the inverse. So this is the inverse, and this one is the graph itself. You can notice it's not really parallel to that line, but anyway, that's what we've got there. I would grab the 2 points you have, invert them, graph those, and that's the graph of that. Let's see what we can do with the next one, number 10. I'm not a fan of that inverse line, so let me create it again. And then down here, that's a little bit better. Okay, let me put on there what we've got. We've got -2, -2. We've got 0, -1. And we have got 3, 3. And this thing does something like that. Okay, we want that inverse. So let me start. And some of you may be able to look at this and draw the inverse all on your own. Yay for you. So I'm going to draw what I've got. I'm going to write down on a T table what I've got. I've got -2, -2. I've got 0, -1. And I've got 3, 3. The inverse, get them up, flop them out. -2, -2, -1, 0, and 3, 3. So this is the only one where you can obviously see that you swap places. The x becomes the y becomes the x. These other two had matching numbers, which makes it a little more difficult to see that. I'm glad this wasn't our first problem to look at. So let's see what we've got. negative 2 will be that one. Negative 1, 0 is this guy. And 3, 3 is that guy. So we're looking at something like that. You can see that those are reflections across that red dashed y equals x line. So that's the inverse. The blue line is the inverse. Okay, let's go look at number 11. 11 says f of x equals 2x minus 3. Graph both. Find the inverse. Graph both. Define the domain and range for both. Okay, so let me come back down here. And let's scoot us up. And we'll finish up down here. I'd prefer that on the other side so you don't have to look at that glare. We'll just put ourselves right here. Okay. First, we've got to graph 2x minus 3. F of x is 2x minus 3. That's in y equals mx plus b form. Let's see, this is number 11. So the slope is 2 over 1. Remember, the slope is always in front of the x number. And then the y-intercept is always 0, whatever sits at the back. So to draw this line, I'm going to begin at 0, negative 3. And then from there, I'm going to go up 2 and over 1, up 2 and over 1, give it another one, up 2 and over 1. I mean, you can go endlessly if you'd like to. So this line looks like that. There's f of x. We are looking to find the inverse and graph it. So f of negative 1 of x is we're going to do the process we've been doing on this other. So that was a little premature right there. Let me move over to here. So this is still number 11, and finding the inverse. So we began with f of x equals 2x minus 3. Let's do that process of getting the line for it. That's one way of doing it. The other way so let me do that and then we'll talk about it. Y equals 2x minus 3. Swap them out. And then begin to get y by himself. Add 3. X plus 3 equals 2y. Divide by 2. And so we end up here with y equals, I'm going to separate it out because that's easier for us to do lines. So y equals x over 2 plus 3 over 2. So the inverse is x over 2 plus 3 over 2. There's our line. The slope is 1 over 2. And the y-intercept is 0, 3 over 2, which is 1.5. I'm just going to write it as 1.5. That's easier. Then you would go over to your board, to your graph. Begin at 0, 1.5. 0 says don't go sideways. 1.5 takes us to just about there. And then we're going to go up 1 and over 2. Up 1 and over 2. Up 1 and over 2. And it'll look like that line. Something like that. That's the inverse. Notice, if you will, please, that if you were to draw the mirror in, that it absolutely does reflect across that. The other way, instead of going through this process to develop the line and then draw that in using your skills as a grapher, is to do what we were doing earlier with the t-table. So I know that f of x has the points, we've found them, 0, negative 3. And then we went up 2 and over 1, so that point is 1, negative 1. And then we found another, this point up here, 2, 1. So the inverse, we'll just have the reverse of that. negative 3, 0, negative 1, 1, and 1, 2. So negative 3, 0 is 1, 2, 3 right there. I missed it by a little bit. Negative 1, 1 right there, and then 1, 2. So they're on that line. So either way, if you would like to grab some points and flip them around, or if you'd like to develop the line and draw it in, doesn't matter. Your choice. Okay, so that gets number 11. Oh, domain and range for both. Okay. These are lines. And the domain, let's look at the black line. Let's look at f of x. The domain for him, what does he use up on the x-axis? This goes all the way down to negative infinity. That goes all the way up to positive infinity. So the domain, f of x's domain, is negative infinity to positive infinity. Sorry about the way that looks. That doesn't even look like anything. But negative infinity to positive infinity. The range for the original function, what are we using up on the y-axis? Again, this goes all the way up to positive infinity, goes all the way down. So the range will match that, negative infinity to positive infinity. If you remember from Thomas's lesson, what we know about the domain of the function, that'll match the range of the blue line, and the range of the function will match the domain of the blue line. So when we go to do the inverse domain, the domain will be this range, and the range for the inverse will be the domain of the original function. Now, that doesn't have a whole lot to do with anything here because they're all the same thing, but that will end up happening to us on other functions, specifically on number 12. We will be able to match the range of one with the domain with the other. The domain for one will be the range for the other. Just in the same way these points get up and swap places, these domains and range will get up and swap places. Okay, let's get rid of this and let's tackle our last problem. I'm going to cram it on this paper some way. I know that that's probably going to give you some glare there. Yeah, I see it down in that lower corner. Let me see what we're doing. -5, so we'll be okay. Just try to ignore that glare there, and I'll do the work over here. Okay, number 12. The function itself is x squared minus 5. Let's graph that first. X squared is a parabola function. Well, you can't see that. Sorry. There we go. Okay. X squared is a parabola function. The vertex point will be, remember it's a liar, and between what sits between the x and the 2. So the vertex point here will be what's between there. Nothing's between there, so 0. And the same as what sits at the back. So this parabola is going to sit at 0, -5. So 0 says don't go sideways. -5 says go down 5. 1, 2, 3, 4, 5 to the dot. So we're drawing it in something like that. On my math lab, and I didn't write it on here, and I should have written it on here, but what we're looking at here, your my math lab problem will say for x is greater than or equal to 0, I think it says. So what that means is that the x coordinates have to be greater than or equal to 0. So these will all work. This piece will not work. This arm will not work. We're just going to get rid of it. That piece of the parabola is just not part of this graph. There are reasons for that. You don't care. So this is what we've got for x squared minus 5, where x is greater than or equal to 0. I didn't write that on my graph, on my number 12, but it should be there. If we were face to face, I'd have tackled that face to face. Now we're just tackling it on a video. So this is our graph. Now what we want to do is we want to do the inverse of that. So the inverse of this function is going to, let's do that routine. So here's what we're going to do. Y equals x squared minus 5. swap these out. X equals y squared minus 5. Solve for y. And then we're going to have to take the square root there of both sides. So y equals the square root of x plus 5. Let me remind you that the parent for this graph is the square root of x. That's the shoulder. But then this is a liar. It moves it back 5. So we're coming back here and doing something like that. And sure enough, you can see, let me pop that in there. You can see that they are reflections of each other across the y equals x reflective line. That's probably the easiest way to do this one. You could make up some points, but you're so comfortable with the idea that this is a parabola and this is a shoulder. So I think you're good there. What else do we need? We need domain and range for both. So let's see what we got here. Let's work on the function first. For f of x, the domain, that's what are we using up on the x-axis. They already told us what we were allowed to use up on the x-axis. That's anything bigger than or equal to 0. So our domain, what we're using up, the black line uses nothing over here. It starts at 0 and goes to infinity. So the domain is 0 to infinity. The range for this black function, remember range is what are you using up on the y-axis. Start down here, nope, 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 nope. Oh, right there is where we start using up the y-axis. That's -5, and that line will take us on to infinity. So we're using -5 to infinity. When you go to do domain and range for the inverse, for the blue, remember these will just swap places. This will be our domain for the inverse, that'll be our range, but let me show it to you so you can see that it actually does work. If we're working on domain of the blue, domain is what are we using up on the x-axis? Nothing back here. It starts using up x-axis at -5. And this blue arc goes all the way to infinity. And sure enough, the domain of one matches the range of the other. Now when we work on range of this guy, that means think about putting this blue line onto the thermometer. So this lowest point matches right to there. Nothing used up with the blue, nothing, nothing, nothing. Here's where we start on the blue range. Goes from 0, and this will continue moving up to infinity. So 0 to infinity. And sure enough, the range and the domain, one of the inverse, one of the regular match. The domain of the function and the range of the inverse match. So that's exactly as promised. I think we're good. See you next time.